Assalamualaikum warahmatullahi wabarakatuh. My name is Shazwan Faris and I will be presenting on the introduction, the needs, analysis and the design specifications for a project named Cassava Peel Machine. First, let's take a look into Chapter 1, which is the introduction to the project. Our project is designed to effectively separate cassava from its skin. The machine is hoped to ease the process of peeling the cassava skin without resorting to much energy-intensive labor. The product is expected to help the entrepreneur community domestically and internationally. With that, the machine is aimed to increase the productivity of food entrepreneurs. As for the problem statement, cassava peeling is a time-consuming and labor-intensive work. To peel cassavas, most small companies hire a large number of contract workers to increase the production rate. To peel batches of cassavas, it requires large workload and concentration to be performed by humans. Manpower will take a long time to peel just one cassava, let alone batches of cassavas that come in at one time. Due to the slow process, the batches of cassavas may turn rotten and become avoidable waste. Other thing to take note is that the quality of the peeled products is inconsistent with each individual. Here we have listed four objectives that need to be tackled for the project. The first one is to minimize human energy in the cassava processing industry. Second, to avoid injuries of workers in cassava peeling industry. The third one is to minimize the time needed to peel the cassava in cassava processing industry. And last but not least, to reduce the amount of rotten cassava due to storing them for a long period of time. For the scope of the project, the production will focus on small-scale industry owners in Malaysia who needs an affordable machine to increase the efficiency of the peeling process. Okay, next we have Chapter 2, which is the needs analysis of the machine. From our market survey, we have come across three different types of peeler that serves similar function as our product, which are peeler, electric peeling machine, and cassava peeling machine. All of these peelers come with respective advantages and disadvantages. The pros of having a peeler are that it is easily operatable, compact sized, and cheap. The cons include being inefficient and involves high risk of accident to occur. For the electric peeling machine, the advantages are that it saves time and imposes low risk of accidentally cutting the user's hand. The disadvantages are that it is expensive and has limited functionality. For the last one, we have the conventional cassava peeling machine. The advantages are that it is highly efficient and can avoid over-damaging of product. The disadvantages are that it is highly costly and causes noise pollution. For the methodology, we performed survey questionnaires at the beginning of the project commencement. The team had distributed a set of questionnaires in the form of a survey. The samples include the students and staff of UNIMAP. Google Forms was used because it is the most feasible channel of needs information gathering, as it is easy to be distributed around a large circle of demographics. The survey was divided into four sections: A. Demographic profile, B. General overview, C. Expectations, and D. Opinions. Section C and D played the most important part of obtaining the customer requirements for the project. Section C acquired customers' requirements in terms of the machine's cost, operating time, capacity, and size. Section D consists of Likert scale questions on the customer's expectations on what aspects the prototype should be built around, and it becomes the building block of the engineering characteristics. From here on, we are going to look into chapter 3, which is the design specification for the product. There were two types of design parameters identification that had been performed by the team. The first one is the house of quality, and the second one is the product design specifications. House of quality is developed to illustrate and measure the customer requirements relevancy to several listed engineering requirements. From here, we can determine the importance, ranking, and how it relates to each engineering requirements. This is important to make sure that we are designing the product as closely as to the customer requirements. In another slide, here is the product design specifications for the proposed design. From this slide, I have compiled some of the main specifications that should be highlighted to explain the design of the product. The specifications listed are product identification, special features, key performance target, service environment, physical description, which is the design dimensions, and life cycle targets. Okay, that's all for me. Thank you.
Hi, my name is Liu Kaishen. I would like to present about concept generation of this project. Firstly, the design of the device was created to facilitate the process of peeling the cassava skin. The aim is to minimize the human energy. However, the committed cost of the design will be the main constraint to build a low-cost device with the right size for a cassava peeling machine. The material for construction of the machine were chosen based on their availability, properties, machinability, and economic consideration. Designing the machine must achieve a balance between the cost of installation and function. Next, I would like to make a small introduction about cassava. Cassava is a plant that belongs to the botanical family. Cassava is the third largest source of a low-cost carbohydrate among crop plants and known to be one of the major crops in the Indonesia, Philippines, and Malaysia. Cassava is important in many developing tropical countries. The products are dried chips, flour, gari, cassava grape. Next is the physical decomposition. A physical decomposition separates the product components according to its main function. There are three main components of the cassava peeling machine, which are frame, electronic parts. The figure shows the system design. The black box of the cassava peeling machine is showing the input energy for our peeling system, which include electrical energy and kinetic energy. The main function of those energies and signals are to peel the cassava when the cassava enters the machine. This is the functional structure block diagram. Initially, this system will be operated when the power supply is switched on. We are going to put the unpeeled cassava into the machine. After that, when the unpeeled cassava is put in the machine, the motor drives the cassava brush to rotate, which causes the cassava and the brush to rub against each other and so that the cassava is peeled by the friction principle. After the cassava is peeled, the conveyor screw drives the cassava to roll forward and transfer the peeled cassava out. Morphological chart is mainly based on the function analysis for the design mechanism. There are several considerations such as type of frame, type of chain, electrical, type of brush, and sprocket. This is the context diagram. Its purpose is to illustrate the inputs and output that are result from the system interacting with the elements. Physical design idea including power requirement, shaft design, and chain sprocket. There are some concept we generate based on the customer requirement. This is concept 1. The machine contains 3 or 4 peelers which attach with shaped blade to peel the skin of cassava. The worker just need to put the cassava in the entrance hole and the rotating rod will move the cassava to be peeled by the blade. However, It's wasting time because workers need to put in cassava one by one. Next, this is concept 2. We incorporate the design of huge cylindrical container which attached with blade to peel the cassava. A motor is installed under the cylindrical container. The motor will force the system to rotate and cassava will be peeled by the blade attached in the container. The advantages of this concept is high amount of cassava can be peeled by time due to the size of the machine. The machine will consume a lot of fuel or electrical energy because of the size and peeling large amount of the cassava at the same time. The figure shows concept 3. We incorporate sharp abrasive brush on the cylindrical rod to remove the skin of cassava. The cassava will be put into the container. The cylindrical rod will be moved by the motor and the friction between the cassava and the abrasive brush will remove the cassava skin. Moreover, screw conveyor will be used to unloading the cassava. Next, this is the concept 4. We incorporate a rotating cassava holder at the bottom of the machine to hold the cassava and rotate it to be peeled by the blade. Last but not least, this is concept 5. We incorporate a rotating fork which is connected to the motor to rotate after the cassava is mounted into the system. There will be two blades attached to the container of the system to peel the cassava. Concept 4 and 5 is not suitable to use in an industry which processes high amount of cassava every day. Besides that, there are several design parameters and constraints that must be taken into consideration when proposing the design of the cassava peeling machine. There are natural cost, power usage, environment friendly. That's all for chapter 4. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fahmi bin Idris. I would like to present about chapter 5 and chapter 6, which is conceptual design and embodiment design. Firstly, I would like to brief about what will be covered in this chapter. This chapter will look into summary of decision making process throughout the course of designing the cassava peeling machine. The process includes the use of two distinctive methods, which are analytical hierarchy process (AHP) and pulp chart. Next, I would like to brief about what is decision making. This will discuss in step in selecting the best viable concept to be designed. The first step is to dive deep into AHP that will weight each concept based on the weighted criteria factor of several engineering characteristics. After that, stages of park selection charts will be made. This concept relies on the use of datum that will determine whether the engineering characteristic of each concept is better, worse, or same compared to other concepts. Table show the final decision matrix for all concept design. Concept 3 is chosen as the final selected design with the highest score, which is 2.608. Table shown in the is the park selection chart 2, which after eliminate concept 4 as it obtained lowest total weighted score in park selection chart 1 and choose concept 1 as the datum. The result is concept 3 is the best selection among all 5 concepts with total weighted score 3. Figure show the sketching of selected concept, which is concept 3. Next, I will go through about the next chapter, which is embodiment design. There are three main activities in this phase, which are key subsystem, schematic diagram, and part layout. Figure show physical decomposition of cassava peeling machine, which consists of motion module, motor mechanism module, power supply module, and peeling module. Peeling module. The major component in peeling module is drum and brush. As the drum rotates, cassava and the brush rub each other and rip off its skin. Power supply module. For power supply module, we use single-phase induction motors as it is a simple motor that operates on single-phase AC. Transmission module. In transmission module, the electric motor will transmit the mechanical power to the shaft where sprocket attached. Auto-moving module. For auto-moving module, the screw conveyor is used to drive or push the cassava from the machine to outside. Washing module. In washing module, the cassava is cleaned from the dirt of mud and soil by using water supply and normal pressure from water tap. Since I have explained in detail on key subsystems, then I will go through roughly in schematic diagram to explain the flow of machine. The first thing to happen is washing process, but before that, we have to load the cassava first, close the machine's door and start machine. The dirt on cassava will be washed by water and it will flow out of the machine. After that, filling process will take place, which the main component in this process is abrasive brush. The screw conveyor will rotate gently to unload the cassava out of the machine. The last process is unload the cassava. The peeled cassava will be unloaded from the machine and the user need to turn off the machine or start loading new batch of cassava. Next, I will explain about part layout of cassava peeling machine. From physical decomposition, these products are assembled from several parts. Different part has different function and may also composed of different material. The first part is electric motor which made of cast iron. Two electric motors are used to produce the machine. The first one is driving the rotatory drum to remove the pieces of peel from the raw material. Another one is to unload the cassava from inside the machine. The second part is screw conveyor, which made of stainless steel. Peeled cassava are driven by screw conveyor to move forward and finally fall down from discharging hole. The third part is roller with abrasive brush, which made of stainless steel. Total of 7 to 8 number of rollers attached with abrasive brush constantly rotate with high speed, effectively peeling skin of cassava. The fourth part is V-bags made of rubber function as power transmission to transmit power from primary source, which is motor, to the secondary driver unit, which is pulley. We use spur gear that made of stainless steel because it has high transmission efficiency and compact and easy to install. Next is power transmission is pulley made of stainless steel, which attached to the main gear and connect to the motor by the belt. We use aluminium as the frame of our machine as aluminium has high durability and low cost. It is lightweight, thus low energy required to move the machine. Next is machine cover that made of aluminium sheet, which used to protect inner part of the machine and avoid the cassava out of the machine. The last part is rounded head screw that made of stainless steel, which will use to attach aluminium sheet to machine's frame. Instead of easy for maintenance, rounded head screw is also strong and wear resistant. That's all from me. And I will pass to my friends to continue the presentation. Thank you.
Hi everyone, my name is Muhammad Zain Ben Zaini and today I'm going to present about chapter 7 and chapter 8 that have been done in order to achieve our objective. So first we will look at chapter 7, which is prototyping. Okay, this is our technical drawing. So here I will show you the major part that we use in our project with specific dimension. So first, this is our frame layout. Then this is a roller brush layout. Then this is a full assembly layout. And then this is a full assembly of product that have been done using CATIA. So as you can see here, this is a cassava peeling machine is consisted of motor, transmission, roller brush, and screw conveyor. In this project, we use two motor, which is one to drive the roller brush and other motor to drive the screw conveyor. In this project also, we use 6 roller brush in order to peel the cassava. And material for the frame, we use aluminium. Okay, this is our working process of cassava peeling machine. First, when cassava peeling machine works, cassava will enter the peeling machine and the motor will start drive the roller brush to rotate, and which is causes the cassava and the brush to rub against each other, and meanwhile the cassava also rubs against each other so that the cassava is peeled by the friction principle. And next, while the cassava is peeled, the screw conveyor will drive the cassava to roll forward and transfer the peeled cassava to the next section. And then the peels of cassava and other debris will fall into collection tanks. Okay, this is our engineering analysis. The three-dimensional model of automated peeling machine that created by Katia is applied to the ANSYS software, which is by using ANSYS Workbench for reviewing the total deformation, equivalent elastic strain and stress. For this product has been analyzed for the peeling parts, which is the abrasive brush, as we can see figure 7.4, figure 7.5, and figure 7.6 that represent the analysis. So in order to run the machine, load of 323.73 Newton was applied from the inside of the machine, specifically on abrasive brush. And then with the equivalent cassava load of 33 kg per ton, from the analysis of the abrasive brush, we get the maximum total deformation is 0.009692 meter, and then the maximum elastic strain is 0.00107, and the maximum stress is 205.78 megapascal. So from that, the maximum stress generated is smaller than yield strength. So from the analysis, we can conclude that the abrasive brush will not undergo plastic deformation at this load. Okay, this is our chapter 8, which will cover bill of material and economic analysis on product. Okay, for the bill of material, we list out all of the necessary parts or components that need to be bought in order to develop a product or a service. And other than providing the list for component, bill of material also serve the purpose of managing the cost requirement for each of the component, so that the designer can keep the cost lower than the budget supply for developing the design. Okay, here from the table 8.1 bill of material, we can see the list for the component that we use in our project. First, abrasive nylon brush with seed quantity that will cost 681 ringgit. And number 2, screw conveyor with one quantity which will cost 480 ringgit 30 cent. And number 3, motor with 2.2 kilowatt with two quantity that will cost 860 ringgit. And number 4, aluminum composite sheet that used to build a frame for the motor. And number 5, which is S304 stainless steel hollow tube with one quantity that will cost 164 ringgit 50 cent. So the total that we get, which is 2,463 ringgit 40 cent. Okay, this is our economic analysis on product. For economic analysis, allow the designer to set up the target profit to be gained from the selling product. The profit can then be cycled back into the production line to have another product be manufactured and put into the market. The manufacturing cost will be taken into consideration when figuring out the total amount of profit that should be taken from selling the prototype, while keeping the price as reasonable through a customer perspective. So here we can see the calculation for gross profit, and its margin are as follows. First, the total for building cost, which is RM 2,463 ringgit 40 cent, and the total net sale RM 2,850 ringgit. And from that we can calculate the gross profit which is net sale minus with building cost. So we get RM 386 ringgit 60 cent. And from the gross profit, we can calculate the gross profit margin, which is gross profit divided with net sale and times with 100. So we get the gross profit margin, which is 13.56%. Okay, so that's all from me. Thank you. Okay, for this part, I will explain about our project simulation using Katia software. Okay, as you can see here, we're using Katia software in order to run our project. From this video, we can see that the cassava peeling machine has two motors, and one is to drive the roller brush, and the other is to drive the screw conveyor with the counter vane in order to guide the peeled material right from the feed pot right down to the discharge pot. And first of all, when the cassava is put into the peeling machine, as shown in the video, the roller brush will rotate and scrap the cassava and continuously flips it. And at the same time, the screw conveyor will drive the cassava to roll forward and transfer the peeled cassava into collection tank. Okay, that's all for our video simulation. Thank you.
Hi, I am Liu Kaixuan. I would like to present about the discussion and conclusion. For discussion part, the concept of the design process is to increase the efficiency of industry kecil sederhana. The design of the cassava peeling machine may help in reduce the time and human energy needed to peel the cassava. Its design is based on the customer requirement obtained from the survey. Decision tools such as weight decision matrix and analytic hierarchy process are used to select the best concept for the machine. Decision tools state that the concept tree is the most suitable concept design for this machine. In conclusion, we have gained knowledge about the mechanism of cassava peeling machine. The objectives for this project are achieved successfully. By the use of cassava peeling machine, human energy can be minimized in the cassava processing industry. The design of cassava peeling machine will also reduce the possibility of injuries of the workers. The time taken needed to peel the cassava is minimized. The design shaft on conveyor screw enable large quantity of cassava to run the peeling process at the same time. The amount of rotten cassava due to store in long time period is reduced. From the simulation of cassava peeling machine, the design of machine can work successfully, and this might be a great improvement in the cassava peeling industry. Thank you.